In a breakthrough that could significantly shift the landscape of diabetes treatment, researchers at the University of Geneva have discovered that a naturally occurring protein, S100A9, might offer a new way to manage or even replace insulin in people with type 1 diabetes. This discovery brings fresh hope to millions living with this chronic condition, signaling a future in which diabetes management could be not only safer, but also far less burdensome. For many with type 1 diabetes, daily life revolves around insulin injections, a therapy that, while life-saving, is accompanied by challenges. Insulin dosing is notoriously tricky, and missteps can lead to dangerous drops in blood sugar or longer-term complications such as cardiovascular issues and reduced life expectancy. What makes the discovery of S100A9 so exciting is its ability to reduce harmful ketone levels in the blood, something previously thought only insulin could do, without triggering these side effects. The researchers, led by Professor Roberto Capari and his team, have spent over a decade delving into the body's natural backup systems for energy management. Normally, when insulin is low, the liver begins producing ketones to serve as fuel. But in uncontrolled diabetes, this process can run wild, leading to diabetic ketoacidosis, DKA, a life-threatening condition. That's where S100A9 steps in. In mice that lacked insulin, this protein not only brought ketone levels under control but also improved blood sugar regulation and lipid profiles, all without causing hypoglycemia. This protein operates through an elegant biological pathway. Rather than acting within liver cells, S100A9 communicates externally with receptors, specifically toll-like receptor 4, TLR4, on certain liver cells. This interaction then activates another protein complex, mTORC1, which safely reduces ketone production. Fascinatingly, this entire process unfolds without prompting inflammation, even though TLR4 is usually involved in immune responses. The dual benefit of metabolic regulation and potential anti-inflammatory effects could make this a game-changing therapeutic option. In experimental models, even mice completely lacking insulin-producing cells lived longer when treated with lab-manufactured S100A9. These results, published in Nature Communications, have been so encouraging that the team has secured 2.5 million Swiss francs in funding to prepare for clinical trials, potentially starting as soon as this year. If human trials confirm what's been seen in mice, the implications are profound. Patients could one day reduce their reliance on insulin, or, in some cases, replace it entirely. What also stands out in this discovery is the forward-thinking nature of the researchers. Rather than simply improving insulin therapy, they are reimagining what diabetes treatment can be. This isn't just about making existing drugs work better. It's about offering an entirely new path that avoids many of insulin's pitfalls. And the implications go beyond diabetes. Because S100A9's mechanism doesn't trigger inflammation and appears to improve metabolic regulation, it may eventually offer benefits for other conditions rooted in inflammation and energy imbalance. To help bring this innovation into the real world, the research team has launched a startup, Diathras, supported by the University of Geneva's innovation ecosystem. The goal? To translate this promising science into practical therapies. With the backing of organizations like the Helmsley Charitable Trust and the guidance of a world-class team, that vision is steadily moving closer to reality. While we're still in the early stages, this development could be a true inflection point in how we treat diabetes. For patients, the potential of fewer injections, fewer side effects, and a more stable daily life is more than just medically significant. It's a meaningful step toward freedom. The story of S100A9 is not just about scientific progress. It's about giving people with diabetes the chance to live with more confidence and fewer compromises. And perhaps most importantly, it's a reminder of what's possible when curiosity, persistence, and purpose come together in the lab.